Okay, we're going to next talk about, as our continuation of the graphs and sine and cosine, we're going to talk about the characteristics of, there it is, periodic graphs, characteristics of periodic graphs. A periodic graph is any graph that sort of repeats itself after a while in a regular manner. And suppose this is, we're looking at a graph here. And let's suppose that this is the, on the y-axis, we're looking at the height above the ground. Yeah, it's not showing up very well. Let me make it a little darker here. If I can get that, get a little thicker too. It's pretty thick. Let's try that. Okay, so we're looking on the y-axis here is the height. Above the ground, like you're riding around on some sort of amusement round. And then across the bottom, we've got a time going across the bottom here. So you're going to start at this graph. You're going to start on this ride. At the bottom of the ride takes you up to 20 feet in the air and then brings you back down to the ground again after 2 whatever time units. Let's say minutes. Let's say seconds. That'll be exciting if it's in seconds, going really fast. So you go up this ride, you go up 20 feet in the air, and you come back down after 2 seconds. And then the ride repeats itself over again, takes you up in the air, 20 feet in the air, and comes back down. And another 2 seconds, you're back down at the ground again. So some of the terms that we typically deal with here are the period, which is the sort of the horizontal distance before the for the graph repeats. In this case, it looks like our period here. So if I go from peak to peak, if I'm looking horizontally, what's that distance across there? Or from the valley to the valley down here, if I come down here to the valley, from that very bottom to that very bottom, it's a 2 second, or 2 seconds period in this graph. That our period would be 2 seconds. So it's the distance from peak to peak or bottom to bottom, or you can go from corresponding point here in the middle to the same corresponding point on the curve 1 cycle later in there. So it's also 2 units. This looks to be about a half, and this one is about 2.5, roughly speaking, in there. 2.5 should be. So it's still a 2 second period in there. The amplitude is another feature. The amplitude is how far is it sort of from the peak, halfway from the peak to the bottom. It's that halfway. So we actually have what we refer to as the midline, is sort of the middle of the graph here. It's the middle of our curve. The midline in this case is going to be 10 feet. It's sort of like your average height, and your amplitude would be also 10 feet. So you're going from the ground, you're going up 10 feet is halfway, so the amplitude here would be 10. And we always list amplitude as a positive number. And so it's kind of half the range. The range goes from 0 up to 20 on the y-axis. I'm going the smallest I ever get is 0, the biggest I ever get is 20. And so half of that would be the amplitude. The amplitude would be 10. And then the midline is kind of there in the middle of a graph. All right, so period, amplitude, and midline are 3 important characteristics of a graph. Let's look at a different one here. Maybe this one is the hours of daylight. How many hours of daylight we see in a year. And down here at 1, well, this might be, let's suppose this is right here at 0 is January 1st. And then this would be like February 1st. And then here's March and April. And so how many hours of daylight are we getting there in this sort of thing? We can also look at the period. And it looks like if I go from this point to the corresponding point over here, it looks to be, let's see, my scale, it looks like is 10. It must be counting by twos, so that actually should be March, should be here. That should be March 1st. March should be here. We're counting by two, so it looks like it's a 12-month period, which kind of makes sense. We're counting by months. About a year later, we'll have about the same amount of daylight that we had on whatever day it is that we're looking. We have the most daylight here about middle of the year, maybe mid to four, it should be the 6th month, about June, we got the most daylight in the year, and then the least amount of daylight in sometime in December typically is there. And so our period is about 12 months, takes 12 months to go through that cycle. The midline, it varies on where you are in the world, but this midline appears to be about 8 hours, right? 10, I'm counting by twos, I think, on the vertical axis. 2, 4, 6, 8, 10. Yes, I'm counting by tens there. 2, 4, 6, 8, 10. So I'm counting by tens. My midline is at 8, and the amplitude of this graph that you're looking at, what does it appear to be? How far are we going from the peak down here to the midline? That distance in here would be our amplitude. Should be the same distance from here to the midline. We're counting by twos, so 2, 4. Midline would be about 5 hours for the midline, or the amplitude. So the middle thing here is 8 hours of daylight, and we get 5 hours. Maybe that's not so realistically. Amplitude there of about 5 in there with this graph, what it is. So important characteristics of any sort of periodic function are the period, the midline, and the amplitude. And well, for here we have the sine and the cosine graph. Y equals sine of x is actually, can I make that bigger? Let's make that a little bigger for us. All right, we'll make it a little bigger there. The red one is in y equals sine of x. Let me switch to red here. Is our graph of y equals sine of x. And the blue one is y equals cosine of x. We'll switch to blue. Y equals cosine of x. And if we look at their periods, I'm measuring things here in radians instead of degrees. And if you look at, say, the blue function, the cosine function, it's repeating here just after 6, which is just actually, the period of that is 2 pi. And it turns out the period for the sine function is also 2 pi. If you look at the center point here where cosine is starting, or sine is starting at 0, its period is also 2 pi. The amplitude is equal to 1 for both sets of graphs, and the amplitude is 1, and what was the other one that we talked about? The midline. The natural midline that we're looking at is 0 for both of those. So sine and cosine both have the same period of 2 pi. They have an amplitude of 1 and a midline of 0 in their basic form in there. So period is 2 pi, amplitude is 1, midline is 0 for sine and cosine. So they're very similar terms of graph. The big difference is sort of where do they start. The cosine function starts up at a maximum value, and the sine function is starting at a midline. So the cosine starts at a maximum value and drops down to the midline and on down to the minimum, and then back to the midline and up to the maximum again. In one cycle, the sine is starting in the middle. So very similar graphs. They behave very much the same. The period is 2 pi, the amplitude is 1, and the midline is 0. But the idea of period, amplitude, and midline are important characteristics of graphs that we will continue to study here in chapter 6.